We have a problem on the principle of work and then energy. So there are four doors of this revolving door and they are attached to axle A to B. So each door is 50 lb thin plate, and this is to use the I value. Okay, I value for thin plate. And then friction at the axle contributes a moment of 2 lb-ft. Okay, and then this one is a friction force and then resists. And then if you remember the couple moment, the 2 lb-ft, we were using the formula here, the moment into the change of angle. And then the woman passes through one door by always pushing with a force of 15 lb. You can see always a force of 15 lb. It is always perpendicular, as I showed here. Determine the door's angular velocity if it has rotated by 90 degrees. The doors are originally at rest, means that the kinetic energy originally is 0. Okay, at rest means that omega is equal to velocity, that's equal to 0. Both are 0. Okay, so let's start. As always, we will have the work principle, energy principle. So we will say that the work done from 1 to 2 changes the kinetic energy of the door. Okay, and T1 we said that is 0 because the omega and then V is 0. And then this term, so we have two work. One is by frictional force, which has 2 lb-ft of couple moment, and the other one is that by P value. Okay, and then we will have the T2 value. Okay, so let's start, then I will come back to this chart here. So the first is that the work by frictional force. Okay, it says that it has a moment which is constant, that is 2 lb. Okay, and then work by mc, if you remember it was md theta. Okay, and then it was from theta 1 to theta 2, and in our case theta 1 is 0, you can see the theta angle, and then theta 2 is 90 degrees. Okay, so that will be that 0 to 90, which is pi over 2. mc is 2 and d theta, that will be 2 pi over 2, that will be pi. Okay, the next question is that is it positive or negative? That one will be just a simple check. The frictional force is this way. Okay, and the door moves that way. And then opposite to each other and therefore negative. So that will be negative and that will be negative and that will be negative. Okay, this is the work by the friction force. The next one is that work by P. How can we find it? So as you can see, the applied to work P rotates the door this way, and then when the door rotates, it will rotate something like, okay, it will rotate something like this one. So path of door that is due to P. Okay, then we need to find what is this one. Let's do that. So we have path something like this one, and then we have the point force P. Okay, and then it starts from here, it ends at, sorry, it starts from here, it ends at here. And then to find it, we know that the work by P will be P dr, and this is the dr. Okay, that distance is the dr, and that distance is r into d theta. Okay, this is the arc length or segment length. So that will be, the p value is constant. The p value is 15 lb. dr, I will just write r d theta. The r value is 2.5 feet. Okay, that is, r is, this r is 2.5 feet. Okay, because the force is applied here. This is the where p value is applied. You can just check it here. The p value is applied here. Okay, this p value is creating a path, something like this one. Okay, this is the, actually the path is this one, the real path. It starts where the point p is applied. Okay, because the force is applied here, it's not applied here at the end, it's applied at 2.5 feet, and then the r value is 2.5 feet, and then so it will be that 15 is constant from 0 to pi over 2. 15 is constant, 2.5 is constant, then it will be 0 pi over 2, and d theta, that will be 15 times 2.5, that times 3.14 by 2. lb feet. Okay, that's for the work due to P. So we have found the work due to couple moment, which is negative pi, and that's negative 3.14, and then due to P, which is 15, that's lb times the feet. Then we have the 59, which is lb times feet due to P. The next question comes is that the kinetic energy at 2. So that one will have the kinetic energy at 2, which is T2. It has two components, then half mvg squared plus half ig omega squared. Okay, and then here the body rotates without the translation. Okay, that's what the body does, and then we will take this term as 0. Okay, so now the time is to find the kinetic energy 2. And then you know that T2 we can write is 1/2 mvg squared plus 1/2 ig omega squared. This is what we can do for this body to write the moment of inertia is ig, and then the mass is the mass of the whole body. Okay, so now let's try to solve